Okay, so what we are going to do here is combine the various elements of neoclassical growth theory that we've been speaking of up until now, the production function, the investment requirement line, and the savings function, in order to establish the complete model of the neoclassical growth theory. The thing to try and bear in mind is what the purpose of us doing this in the first place was. Remember that we started off with growth accounting theory, where growth accounting theory enabled us to try and understand what the different inputs contributed to economic growth. So growth accounting theory was able to explain how different inputs contributed to total output growth. But to go a step beyond that, to try and understand how we accumulate the inputs we need in order to achieve economic growth, that's where neoclassical growth theory comes in. And what we've been doing up until this point is going through the various components that we will need to try and understand neoclassical growth theory. So this is the session where we put some of those elements of the neoclassical growth theory together. To remind you, we started with the production function. And the production function showed us how, when we increase capital stock per person, output per person increases. In addition, capital stock per person could decline, and then output per person would decline too. But in general, because this is a growth theory, we typically talk about increases in capital stock per person relating or causing increases in output per person. I'm going to draw the set of axes because what we are going to do is put our production function into our set of axes, into the capital per person and the output per person space. So remember to always label your axes: capital per person on the horizontal axis, output per person on the vertical axis. Alright, if you recall, there's a positive relationship between capital stock per person and output per person, and therefore the graph that or the curve that I'm going to draw has a positive slope. But you should also remember that the slope of the production function is bowed out or concave. That means that it's not a straight line. And essentially, the bowed out or the concave shape derives from the fact that we assume that the relationship between capital stock per person and output per person is subject to diminishing marginal returns to capital stock. So diminishing marginal returns to capital stock means that when capital stock per person increases, output per person increases as well, but at a decreasing rate. In other words, each consecutive equal increase in capital stock per person will cause output per person to increase, but by smaller and smaller amounts each time. The next thing that we considered was the investment requirement line, because we said to ourselves, okay, if we need to increase capital stock per person to increase output per person, what do we need in order to be able to increase capital stock per person? And what we need is investment. So our investment requirement line is a positively sloped line, and the amount of investment required is dependent on the population growth rate, denoted by a little n, and the depreciation rate of capital, denoted by a small or little d. The investment requirement line is positively sloped. It tells us that for any given amount of capital stock per person, there needs to be a certain amount of investment per person taking place in order to maintain that level of capital stock per person. In addition, the investment requirement line tells us that if we wanted to increase our capital stock per person, we would need to have an increase in investments per person in order to be able to do this. With the investment requirement line, it's really important to remember that the amount of capital stock per person will in fact decline without investment. The reason why capital stock per person will decline without investment is because of the population, which grows each year, and because of the depreciation of capital stock which takes place. Both of these things, increasing population levels caused by the population growing, and the depreciation of capital, which causes capital stock to lose value or become worn out and obsolete, those two things together will cause capital stock per person to decline unless there is sufficient investment per person taking place to maintain the existing capital to labor ratio. If we wanted to then increase the amount of capital stock per person, we would need to have investment per person over and above the amount required to keep the capital to labor ratio constant. The final curve that we are going to add to our axes is the savings function. And if you recall, we spoke about the savings function where we said that we would assume that there is a constant savings rate in the economy. In other words, that on average in an economy a certain amount of output per person is saved. And the amount of output per person saved is going to depend on the savings rate. We also said that the savings function has three characteristics. It's firstly positively sloped, because as capital stock per person increases, output per person increases. And if output per person increases, then savings per person will also increase. The next thing we said is that the savings function follows the same shape as the production function. This is because if output per person increases at a decreasing rate, and savings is a constant percentage of output per person, then savings per person must also increase at a decreasing rate. The third point about the savings function is because we don't typically save all of our output per person, then the savings function will lie below the output per person function or the production function. So let's draw our savings function in, and I've labeled it as follows. Oops, is equal to SFK. Okay? In fact, let me just cross that out so that it's clear. That's better. Okay. So also note is that all of these curves intersect at the origin. Okay, and that's because when the capital to labor ratio is 0, then there is no capital stock per person. If there's no capital stock per person, there's no output per person and no savings per person. All right. The key point then, this is together, all of these curves represent the neoclassical growth theory. And one of the most critical aspects of the neoclassical growth theory is a concept called steady state. Steady state on the diagram refers to where the investment requirement line and the savings function intersect each other at point A. And in fact, this is such an important point that we are going to label the level of capital stock that's associated with that intersection, as well as label the level of output per person that's associated with that intersection. And what is going on at this level or at the steady state that makes it such an important point? Well, at the steady state, that is the point where the amount of savings being generated in the economy is exactly equal to the amount of investment required to keep the capital to labor ratio constant. And similarly, if the capital to labor ratio is constant, then the amount of output per person is also constant. What does it mean when we say constant? Well, we mean that at steady state, so at steady state, which here I've labeled A, there is no change in the capital to labor ratio. Capital per person is constant. And similarly, there is no change in output per person. The growth rate in output per person is 0. Okay? This doesn't mean that the economy is not growing, but I'm going to talk about that in a different video. For now, the important thing to note is that at the steady state, the capital per person growth rate is equal to 0, and the output per person growth rate is equal to 0. That's not to say that capital per person is 0. Capital per person is not 0. Capital per person is K star. Output per person is not 0. output per person is a positive value. It's equal to Y star. What we are saying is that these values are not changing. So if the capital to labor ratio was 100, it would remain at 100. And if the output per person was at 1,000, it would remain at 1,000. Okay? What we are saying is that the change in the capital stock per person and the change in the output per person is equal to 0. To understand a little bit better why this is a steady state, it's useful to think about points on the graph where there is no steady state. So I'm going to pick a point at a level of capital stock K1, and at that level of capital stock per person, the amount of output per person generated would be Y1, and the amount of savings per person when capital stock per person is K1 is S1, and the amount of investment per person when capital stock per person is K1 is R1. Now, what should become immediately clear is that at a level of capital stock per person below the steady state level of capital stock per person, the amount of savings per person is greater than the amount of investment per person. And in fact, you can see that the red line lies everywhere above the investment requirement line. So the savings function is everywhere above the investment requirement line all the way until point A. So this means that for all the levels of capital stock per person which are below K star, savings per person exceeds investment per person. Now, why is that relevant? It's relevant because when savings per person exceeds investment per person, this means that the pool of funds that firms in an economy have available to them to borrow from is in surplus. There are excess funds which firms can have access to borrow to invest in capital equipment. What this means is that there's not just sufficient savings to maintain existing capital to labor ratios. In other words, to maintain a level of capital stock per person of K1, you only need R1's worth of investment, but you can access savings all the way up to S1. So the amount of investment that can take place is actually greater than the amount of investment needed to maintain the existing capital to labor ratio. And so, because savings exceeds investment, it's possible for firms to borrow these excess funds, invest in purchasing more capital stock per person, and as they purchase more capital stock per person, the capital to labor ratio will increase. And as the capital to labor ratio increases, output per person in turn will increase. So between 0 and K star, output per person is growing. It's getting bigger and bigger and bigger. And capital stock per person is growing. It's getting bigger and bigger and bigger. Note though that the increase in output per person is not a constant increase in output per person. Why? Well, the reason why, when capital stock per person increases, output per person doesn't increase in a constant manner is because the shape of the production function is characterized by diminishing marginal returns to capital stock. So, when savings per person exceeds investment per person, firms can purchase additional capital equipment. This causes the capital to labor ratio to increase. As the capital to labor ratio increases, output per person also increases, but it increases at a decreasing rate. As output per person increases at a decreasing rate, note that savings per person is also increasing, but at a decreasing rate. And this is how we end up at a steady state, because as the capital to labor ratio grows, and as output per person increases at a decreasing rate, savings per person also increases at a decreasing rate, but the amount of investment per person needed to maintain the growing capital to labor ratio increases at a constant rate. and in particular the rate at which the amount of investment needed to maintain these higher capital to labor ratios increases, is equal to the population growth rate plus the depreciation rate of capital. That's the slope of this investment requirement line. So because savings per person increases but at a decreasing rate, while investment required increases at a constant rate, this gap between savings and investment gets smaller and smaller and smaller until eventually there is no excess of savings over investment, and at the steady state, the amount of savings being generated in the economy at a capital to labor ratio of K star is just enough to be able to accommodate the amount of investment needed to maintain that capital to labor ratio of K star. And if that capital to labor ratio of K star is maintained, then the amount of output per person that will be generated is equal to Y star. Again, the important thing to note is that at this steady state, capital stock per person no longer increases. It will remain constant. The growth in capital stock per person is equal to 0. The growth in output per person is equal to 0. But output per person is a positive number, and capital stock per person is also a positive number. Now, what I would like you to do is to think about situations where the investment requirement line lies above the savings function. And what I would like you to do, think of it as homework, is to think about how the economy would then move back towards the steady state, because that's what's going to happen. A steady state means that the economy is driven towards that steady state. At capital to labor ratios below K star, the savings function exceeds the investment requirement line. At capital to labor ratios above K star, the investment requirement line is going to be greater or lie above the savings function. And so what I would like you to think about is how you could then explain the movement back towards the steady state that would happen if the amount of investment required exceeds the amount of savings being generated at these higher capital to labor ratios. What we will then be doing in future sessions is to try and understand how this steady state can be affected. Because ultimately, this is a theory of economic growth. But if you've been thinking to yourself, as we've been going along, okay, but where's the economic growth? Please don't worry, there is definitely economic growth in this model. The economic growth rate, the overall aggregate economic growth rate is positive, okay? What's not happening at steady state is a change in living standards. Living standards, as measured as output per person, are constant. They are equal to Y star. And the amount of capital in this economy is also constant. It's equal to K star. So in steady state, there is no further improvement in living standards, but there is economic growth. And it's that aspect which we will try and disentangle in later sessions. And we will also start to think about how we could cause or adjust the elements of this model to try and improve living standards in a country. In other words, if we don't want to remain at steady state A, what could the governments in this economy do to try and ensure that living standards do improve over time?